Alright, good morning everybody. Today I will be discussing GRACE, the Gravity Recovery and Climate Experiment. Now most of you have no idea what this is going to be talking about. However, before we get into what it actually is, I would like to discuss a little bit of background about what it can do for us. So to get started on this, I would like to begin talking about an aquifer. An aquifer is a storage material of rock that can hold groundwater. It's very important because it is not infinite, as people have believed in the past. So groundwater is important to us because over 2 billion people rely on it with drinking water. And over half the world's irrigation water comes from there. This is really important because if we're going to have food security in the future, it's important to know where our water is coming from and how much is available to us. We're great at measuring surface water, but unfortunately are very poor at measuring groundwater. Especially groundwater changes over time. We really don't know how much there is at a current point or what happens after a drought, say. This is a pretty dangerous problem. So, is GRACE the solution? Well, no. However, the GRACE satellites are. So, what is GRACE? GRACE is 2 satellites launched in 2002 through NASA. They orbit the Earth at 500 kilometers elevation, and they're spaced 220 kilometers apart. So they orbit the Earth 16 times a day, and through the use of radio waves, measure the exact distance between each other down to the nanometer. This calculates the gravitational strength across the Earth's surface as they go around. So how can this be possible? How do they do this? Well, we need to learn about gravity first. So gravity increases as you have more massive objects. So the gravity is stronger over a mountain than a lake due to the extra mass. So as seen here, this mountain would have higher gravity than the lake in the foreground. So as the 2 satellites are flying over top of the planet, the topography is changing and they are going up and down, and the distance between them is getting closer or farther apart. So because this is accurately measured, we can tell the exact amount distance between them, and from that we can calculate the gravity below them. So this happens every 30 days for an entire global gravity picture. So how are we interested in this? Well, over time, from season to season and from year to year, the gravity maps that we've been getting are actually changing. So does this make sense? Well, it actually does. Because the rocks and all the stuff on the Earth that are stable, they don't really change, we would expect to see a constant gravity map. However, water is the main thing that fluxes over the years and over the seasons. So as we can see here, from the dry lake to the wet lake, just 6 months apart, that will change our gravity readings. And we can extract this information and measure how much water is on the surface of the Earth. So as we'll see here in the next slide, through daily and monthly variations, we can see that in the summer and in the winter, the normal range of monthly water storage varies. But from season to season and from year to year, this is pretty regular. We can have the average of this. What GRACE does is shown on the top slide here. It calculates this variation over the lifetime of the satellite so far, and we can determine the actual amount of differences from normal dry conditions. So that's the total storage. So as seen here, a few calculations. So we can calculate groundwater from this total storage by subtracting the storage of snow, storage of surface water, and the storage of soil moisture. We can accurately measure these without the use of satellites, as been done before. So calculating the groundwater in this way is pretty useful. So what this actually does for us, as seen here in the Colorado Basin, during the droughts of the last 10 years, we can see a major groundwater shortage versus the surface water. So if we were just measuring our total water storage based on what we see on the surface, we would be way off. In here, it's 20 kilometers cubed missing. So, problem solved. Who knew that satellites could be so useful? So you might be wondering, is this all it can do? No, this actually has many other capabilities, including we can calculate the mass of the changing polar ice caps, we can measure changes in water resources on land, understand shallow and deep ocean current transport, understand sea level change resulting from ocean temperature, understand ocean mass exchange, understand the forces that generate Earth's magnetic field, and last but not least, we can measure the Earth forces that move tectonic plates and result in earthquakes and volcanic eruptions, all with a few more calculations. So, is it worth $127 billion? That's up for you to decide. Thanks for listening. Hope you learned something. Thanks for being my primary and secondary reviewers, and thanks for Dr. Nagati for putting this all together. Here are my references, and I hope you've enjoyed the show.